So for this week's programming video, I wanted to set the clock back a little bit. So in 1994, I was a physics student at the University of Wisconsin River Falls. I'd been a DOS user for a long time before that. In fact, had been writing my own utilities for the command line to make the MS-DOS command line even better. Well, in 1994, I started to see interviews and articles in tech magazines about how the next version of Windows would completely do away with DOS, right? I mean, so I said to myself, you know, if you look at what Windows 3.1 looked like, if Windows 3.2 or 4.0 looks anything like Windows 3.1, I don't want anything to do with it. I said I'd rather write my own version of DOS and keep using DOS. And that's what I did. So because I've been writing my own commands, I sort of picked up the DOS command reference. This one's from version 5. And, you know, the manual has, you know, usage and things like that, but it also has a lot of different definitions of commands. And so you can look up in this manual what the different commands are and the command line options and what those commands do. And I said, well, I've been writing my own utilities. Some of them expand on what the MS-DOS command utilities are, but let's try to actually write my own versions of some of these, DOS commands. And so that's what I did. I sat down and I started writing my own versions based on what was inside the manual. So let's kind of take a look today at some of the code that I wrote back in 1994 as sort of a way to wrap up the programming video series. So let's kind of take a look at it and see if any of it kind of stands up today or what I would change if I were to go back and do it again. So I'll put a link to this archive on the video description, but you can get I found a copy of the DOS utilities that I had posted. It looks like this is dated 1995. There's a lot of files there. So one place to start is there's this make file. And so if I just do a more on the make file, you can see here, this is what I wrote for the original version of FreeDOS. Yeah, in the original days, even though this is dated 1995, I think this is actually the original version from 1994, because I stopped using the hyphen on FreeDOS just a couple of weeks after we had launched the project on June 29, 1994. So this archive probably dates back to June of 94, maybe July of 94. And you can see a couple of things here. So the CC line, the CL, and the AS, that's all from Quick C is what that's showing. And we'll look at that in the files themselves. And so you got some options here as part of compiling. And then down here, oh yeah, and it says here, as of today. So the date of this file is actually the end of 1994. So I'm not quite sure why I had the hyphen in FreeDOS. The hyphen should have been gone by that point. But anyway, I had a couple of programs here you can see in the all line, break, CLS, date, del, find, help, more, pause, reboot, T, time, type, Unix to DOS, and vir. So we've got a mix of original MS-DOS commands and some Unix commands, because I'd been using Unix at school as well. So you can see here, it looks like I already made a comment here that break no longer has associated code with it, which kind of makes sense. And the other ones are, I took a look at this earlier, a lot of the other programs are really simple. So it's actually a good place to start if you're learning C, to kind of see what I was doing as a beginning programmer. Now remember, this is when I was still very early in my programming, and so please be kind. So this code will not be good. So let's look at let's look at bioskey.c. And so I know this is very short, so I can just type it out. So type bioskey.c. So I did a lot of these little things where they were basically wrapper functions. So a wrapper function is intended to sort of wrap around, as the name implies, another function. So that way, if you're changing compilers, you only have to change, some of these wrapper functions to get it to do what you need to do, and you don't have to change the rest of the program itself. So Quick C had this function in here for getting the next key press, and so I called it BIOS key as a way to grab the key from the keyboard. This also might be get ch as another way to pull a key from the keyboard. So you can see this is an example of a wrapper function. Also, you can kind of see a little bit the coding style I was using at the time. So I had the comment block at the top that was just a solid line of stars And that was a nice visual break, so that way if I had more than one function in a file, I could kind of see where they started and stopped. Why I didn't have one at the bottom, I have no idea. I guess that was just the style I was using at the time. But you can see I also indicated here what compiler I'm using. That's very helpful. But down there in the while, it's very interesting that I don't actually use braces. My style today is, even if I'm going to have one statement inside an if or inside a while or inside a for, some sort of a loop statement, I'm going to still wrap it around with the curly braces. And I'm not doing that here, and I find that very interesting. The reason I wrap it now today is if I would need to add other functionality to that, if statement or whatever, I can just insert it without having to worry about it. Now I have to go back and now insert the curly braces, because that way lies bugs. So let's look at blank.c. So we'll just do a type on blank.c. I won't do all of these files. I just want to look at a couple of them here. So blank.c. There's some stuff up top that is the comment block that calls us a GNU GPL program. So here we're seeing a function that determines if a string is entirely white space or not. And so it's pulling FreeDOS.h. We should look at that in a second. But another thing I want to point out is, notice it's the argument for blank, char szbuff. So that is what's known as Hungarian coding notation. And basically at the front of the variable name, you're going to put what kind of variable it is. And so sz means it's a null terminated. The z implies it's the end, a null terminated string. And that's what that is. So it's a buffer that happens to be a null terminated string. So that's what szbuff stands for. That's what Hungarian notation is. And you can kind of look it up on Wikipedia if you want to see more information about it. Again, I'm not using curly braces around the for statement or the if statement. I find that very interesting. These days, I would always make sure to include curly braces. I think it just makes my code a little easier to read. And then again, if I need to add some other functionality in there, I can just add it inside the curly braces without having to go back and fix it again. Otherwise, if you tend to not use those curly braces and you add another statement, thinking it's part of the if or part of the for without the curly braces, you're going to get a bug. And so these days, I would just kind of not do what I did there. Let's look at FreeDOS.h. So we'll do a more on FreeDOS.h. And you can see here, this defines a number of things that looks like I'm using inside my my programs. And so max string is the maximum length of a string. And then I had these different formats that I think at the time I thought it was just easier to have everything have the same format for, like a help message or a usage statement. So you can see here, it's at the top, it's got a format for what the program is. And so %s is a string when you're doing it in printf. So it would print the name of the program, a colon, and then a short description, like a one-line description of what the program was. And then format usage, that line is just giving me a straight usage statement. So again, the name of the program and then all the options that sit behind it. And then for each option, there's a format option definition or FMT opt. And that's how I provided the standard indentation for all the different options. Interesting that I would do that. These days, I don't know that I would do that. That's kind of hiding the format statements. I think these days I probably also wouldn't indent that text nearly as much with those spaces at the front. I probably wouldn't even indent them at all. But that's what I was doing back in 1994. You can see again, this was modified at the end of December 1994. I had some macros for printing out the program name and the usage and the options. Again, these days I probably wouldn't do that. I think back then I probably had just learned about macros and I was probably trying to apply it everywhere. It's one of those things where once you learn something, you kind of want to use it everywhere. And so that's what I did. You can see here, there's also some definitions for standard strings for more and end. These days we would use cat-s or the kitten library to pull strings out of a catalog, and we just make sure that the strings are standardized there. So if you haven't used it before, the kitten library or the cat-s library is a library that I wrote way back when that actually changes or lets you look up different strings in a what's called a message catalog. And that means you can have one message catalog for Spanish, another message catalog for English, another message catalog for Italian. And then it will look up that text or a message number from that catalog, and you can use that as what you want to print out. So instead of actually printing out the word more, you would look up what the string is for the language that the person is using, and then you'd use that string out of the catalog instead of more, which is going to be like the local translation of what more is, or end, something like that. You can see I've got new line definitions for Unix, Mac, and DOS. I also have defined true and false very helpfully, which is interesting. And so I've also indicated the version of the FreeDOS release, which isn't actually like the FreeDOS distribution like we think of it today. That FreeDOS version is really like the version of the utilities that I'm releasing here. So that's kind of a misnomer. It's a little bit misleading. It's not meant to be the actual, like version of FreeDOS. It's meant to be just this utilities package. This is DOS Utils 1.0. Let's look at what else we have in here. We've got a CLS .c. So let's look at that clear screen program. So let's do let's bring it up in Fed. So we'll look at CLS.c. And so again, here at the top, I've got a comment block that tells me this is GNU GPL. And then I've got this other comment block that is what my program is about. So again, starts with that single line at the top is sort of a visual break, and then a brief description about what the program is and who wrote it. Now, interestingly, I'm not giving my email here. I probably should have at the time, but I guess I didn't think to do that. And requires ANSI sys. Oh God, I'd forgotten the original version required ANSI sys. So why I wasn't using BIOS to clear the screen, I guess I couldn't tell you. But the looks like I was probably thinking, oh, Linux's terminal is based on ANSI, so maybe we should mimic that. Maybe that's where my theory was going. I'm not quite sure. But everything here does require some sort of an ANSI sys driver loaded. And so down here, there's my include statements. And then here's my get op, so I can parse the command line, and FreeDOS.h. And then I've got some colors that I'm defining for myself. And then, well, here's my main function. And it doesn't declare a type from main, right? So you can see here it's empty. Usually I would put an int on that. So why I didn't put an int main on that, I guess I couldn't tell you. I'm going to chalk that up to beginner programmer, and I just didn't think to put int main on that. And so again, here you can see more examples of Hungarian notation. So I for, I bold, I back, I set. Those are all integer values because they've got an I out front. Also, this is something I've been guilty of for a long time. Just single variable letters. That's not good practice. And my only excuse for that is two things. One is I originally learned programming by programming on an Apple II type system, and so that gave you AppleSoft Basic had up to 2 letters for variable names, and so I got very good at like making variables that were I got very much in the habit, I should say, of writing variables that were 1 or 2 letters in length. Also I also learned Fortran as my first compiled language, and anything that was I through N was by default, or could be made by default, an integer. And so I tended in Fortran programs to do I as some sort of counter, and nobody told me not to do that, so I just did it. And so I was guilty of using single letters like int I for counting through something quite a lot in my early programming days. And actually, even until recently, I was still kind of tended to do that. If you looked at my programming guide, you'll see int I quite a bit as quick counters. In larger programs that I write, I would never use a single letter variable, or at least I would try not to. Here you can see that's where the that single letter is being used. Here it's being used for wow, bad me. What is I doing in this case? Well, I at this point is it's not actually iterating through anything. It's grabbing the next call to get opt. And so get opt is a function that will get the next option on the command line. So you need to pass it argc and argv from the main function. And then this list, this string, these list of single letter options. And this is getopt is originally from Unix. And so uppercase and lowercase options were meaningful in Unix. And so that's why you've got a lowercase and an uppercase S for the CLS command, because we need to be able to accept both of them. I was basically rewriting a version of getopt. If I didn't actually grab a version of getopt that somebody else had written, but I think I'd written getopt, or I know I wrote a version of getopt, and so it might have been this one. So in this case, I isn't even counting anything. It's grabbing an option letter. So very bad programming habit for me. I should not have misused that variable that way. And so there you can see in my switch statement, I've got both capital S and lowercase s as my case statement, and that's going to set an option here that I think this one, for this version of CLS, if you gave it a /s, it would only set the color, not clear the screen. So that's what that's saying here. It's only set the color and not clear the screen. So I would probably use a different function or a different variable name for that to make it a little more clear, like set only or something like that. But there you are. This default, by the way, means that if it doesn't, if it hits an option that it doesn't recognize, it's just going to go ahead and print the usage statement, and then I think that function, which is defined up here, by the way, I think that function usage is probably exiting on its own, because I don't see it exiting, like doing an exit statement or a return statement here. So it must be exiting on its own inside the usage statement, which is also kind of bad practice. These days, I try to write programs that if you know, when the program exits, I try to make sure it exits from the main function. I try to use return these days rather than exit, although I do sometimes use exit. Again, just habits I picked up way back when. Now here we actually are using I to actually look at a number, but actually it's not. It's probably going to be using a for statement down below here. Oh, no, it's not. Wow, it's actually not doing a for statement on this one. So here it's just holding on to, this is where the I opt-end is the argument list index after we're done parsing the command line. So that's what we're looking at here. And so we've got some a statement here. This if is looking for, basically it says if argc minus that opt-end is greater than 0, that means I have other options on the command line left. And so that's going to be looking for a color on background color. And that's what it's looking for here. And so I'm doing some manual parsing of the command line. strcmpy is basically it's a case insensitive version of strcomp. And strcomp is going to compare two strings. So it's comparing what was given to me on the command line, and then it's comparing it with the word bright. And so that's going to say, okay, should I be turning on bold text? And then it does an I++. Wow, this is kind of a weird way to parse a command line. I think I would do this way differently today, but that's what I did back then. So down here, obviously, it's kind of skipping through the command line, checking for foreground, checking for the on, checking for background. And then, here's where it prints the color string. So here in this printf statement, it's put in a whole bunch of stuff, which is this \033. I think that should be an escape statement. And basically that starts an ANSI string, and so the ANSI string is going to set a color, and so it's going to set looks like bold, foreground color, and then background color, and so that's what that statement does, and it ends with an M statement. And then down here, the escape 2J. Open bracket 2J, that looks like that clears the screen. It's been a while since I've seen my ANSI escape codes, but I think I'm pretty confident that clears the screen, because what this is saying is if it's not set only, I would not quite write that these days, but if it's not set only, then print out the ASCII escape sequence that clears the screen. Again, weird to see here in this if statement that I'm not using curly braces. The same up here, I'm not using curly braces. These days, I would definitely put things inside curly braces. I know it's a little bit more code to write, but it makes it a little more readable, and I think that's better all around. And then here, back then I was writing my main function with an exit statement rather than return. Now inside the main function, exit and return, I believe the standard says they're basically the same. I don't think there's anything that's different because it's going to run all the functions that add exit, which is a different queue that when you get more advanced in programming, you can kind of learn about that. So they should both call that from the main function when you're either doing return or exit from the main function. But exit can be called anywhere, and so that's probably why I was using exit. And so here's the usage statement. So you can see here it's doing the program description and the usage description and the option. And so the reason it's using this print P, print U, print O is this way all the programs, as long as they use print P, print U, print O, it's going to format the usage statements exactly the same on all of them. And I think at the time I probably thought that was very clever. These days I think that kind of adds a little bit of complexity that doesn't really need to be there. I would probably just make sure that all the statements are formatted correctly in the way they're supposed to be. And you can see here, yeah, the usage statement has its own exit statement, which is very interesting. I don't know why I did that. I probably should have just printed the usage and then up above, after calling usage, actually exited with my own statement. And then I could actually have a different exit return code if different things happen, right? So if it hit a help at the top, I might exit with one value, or if it couldn't parse the command line correctly, which is what's happening here, then it would dump a usage statement and then exit with a different return code. So that's what I would probably do these days. Looks like that's the end of the function, so we can go ahead and quit that. There's that get opt. Let's take a look at that get opt real quick. So we'll do a fed on get opt.c. So looks like what I had done here, this is the original GNU get opt function. And I made a note up at the top here that this has been altered. And so looks like at the very beginning, I said probably not fully debugged. And I, as I say, I think I recall that I wrote a new version later on that was, I think, from scratch. So that one would have been the better one to use. So this is converting all hyphens, because Unix uses hyphens for option letters. Going to convert all those to slash. And that way it's going to be using the DOS style of command line options. And so I don't know, I need to go through the rest of this file. This is probably going to be, let me sort of do page down, probably quite long. And this, as I said, isn't something I wrote myself. This is something I picked up from the Free Software Foundation. So it's just, something you can use as long as it's GNU GPL. As long as your code's GNU GPL, you can certainly reuse other GNU GPL programs, and that's what I was doing here. Let's go ahead and quit out of that, and then let's look at one other thing here. Actually, there's a get key. I want to look at the get key. So let's look at get key. It looks like another wrapper function is my guess. Yep, this is a wrapper function. So this is a wrapper to get ch. Why I was doing get ch? Well, it says right up there. I guess some compilers don't already do provide a get ch, and so this is an interface for those that don't. So I was probably being clever and thinking ahead. Although I think get ch is pretty common. I think every compiler probably includes a get ch function. But maybe I was using a compiler at the time that didn't. Certainly QuickC did, because otherwise I wouldn't have been able to write this file. And Borland, I'm almost 100% positive, had a get ch function. But I used a lot of different compilers, and so maybe there's a compiler that I used at some point that didn't have a get ch, and I'm like, well, I'll just create a wrapper function for it. But again, this is, wrapper functions are handy, but they're also can be abused. This is one of those that's, I think, being abused. So this wrapper function really just wraps a call to get ch. That's all it does, which is a pretty lightweight, get ch or get key function. It's going through a little bit of overhead to make a function call. I guess this way I didn't have to, as I say, guarantee that the compiler I was running on had a get ch. If they didn't have a get ch, I would just be able to modify the get key function. But as I say, I think these days, I think we can assume every compiler probably has a get ch. Oh, by the way, something else I'm noticing on this one. So if you followed along in the programming video series, you notice that I was using well, I'm doing the same thing here. I've got the functions type on a separate line from the name of the function. But in my other video series, I didn't have this space after the function name before the open parenthesis. And it looks like back then I have a different coding style. So I actually had that space between the function name and the parenthesis. It looks like I'm doing the same thing down here for return. And I think these days I probably would use a parenthesis on return. Why? Because this is not, strictly speaking, an argument. Return just takes a single number. It's not really return's not a function by itself, and so the parens here are really just to wrap whatever statement I'm making. Here, the parens aren't really necessary around get ch, but it does make it a little bit extra readable. Actually, I take that back. It is actually necessary here, I think. Nope, actually not. Now I think about it, it's not necessary because this is a function, and the function will get called regardless. But still, the way I tend to program is, even today, is that if I'm returning the value of a function, which I probably wouldn't do anyway, I'd probably put it into a variable and return the variable value. But here, if I would do something like this, where I'm returning the value of a different function as a wrapper, I probably would include it inside these parens by itself, and that way I know that the value has been completely wrapped. And if there's a compiler out there that does something a little bit weird, that's for me is better programming practice. And let's see if there's one other file we need to look at on this one. So let's look at that. Well, let's look at lines.c. What is that? Let's look at that one. So we're going to do a fed on lines.c. So I can tell already this is going to be a wrapper function of some kind. Oh, no, it's not. It's actually got some other stuff in it. So here I'm including the graphics library. Looks like it's returned the number of lines per screen using a graphics call. Oh, actually it is. It is actually just a wrapper function. I could have just called get video config by itself and just use that in my program, but here I wanted to make a wrapper functions, probably so it felt like it was a little bit more portable. And certainly, when you're talking about things like graph.h and con.io, different compilers will do different things. It is kind of a non-standard library at that point. So I was making a reference here to making it a wrapper. But you can see here the call to I've got a structure instead of an actual variable. So you can actually use a structure to define a variable, because you're basically saying it has that structure. And that struct video config is defined inside graph.h. And so the ampersand indicates this is a pointer. And so that means get video config is going to populate the variable VC, because this is telling it to reference the VC as an address rather than as a variable itself. And then I only need to pull out the number of text rows, and so that's what I'm doing here. So looks like a lot of wrapper functions in this early code. So would I write my code the same way? I probably wouldn't. I'm also seeing in these a lot of programs that are a lot of files that have like one function in them. In these days, I'd probably consolidate some standard stuff into into fewer files. So not everything had to be its own little file. Or I would probably combine the things that we're pulling stuff for the screen into like a screen.h or screen.c or something, rather than doing what I'm doing here. But that's what I did at the time. Oh wow, actually stir copy. Let's look at that real quick. I just noticed that on the screen. So we'll do a fed on stir copy. Yeah, and so this is a wow. Why am I? This function acts as an interface to a compiler-specific function to compare two strings without regard to case. I thought stir case comp actually was a standard function, but maybe I'm misremembering it. Maybe stir copy is the way to call in the native one. But I don't think it is. So here I'm doing a wrapper because it looks like I thought there was a compiler specific function, but I think stir case comp actually is the function you're supposed to use rather than stir copy. But again, another one of those cases where I'm pulling a wrapper as a way to get around compiler specifics. At least that's what I was thinking at the time. So just kind of want to take that quick look down memory lane, kind of see what I was doing in 1994 when I was writing code. So if you're getting started in programming and you're wondering, is my code look any good? Well, if I look back at my code from 1994, this isn't that great either. So don't worry about the code you're writing. You will get better over time. And so just you'll get better through practice. And so if I look at this code back from 1994, I'm a little horrified at some of the coding styles that I used and some of the ways that I was writing. But, you know, it worked. And from there, we were able to move on and make something even better. And that's what programming is about. You're going to write something and you're going to make it even better. And you're going to share it with other people. That's what open source is about. You're going to share it with other people so they can see it. They can modify the source code and they can help make that program even better as well. So over time, by sharing your programs, you'll get better and your programs will get better. So I'm going to leave it there for this week. So before I go, I just want to thank everybody who's supporting me on Patreon. You really do make this channel happen. I really appreciate your support there. Some of you are sponsoring me at a higher level, and I wanted to thank you here. So thank you very much for that. And that's it for this week on the programming video. Visit our website at freedos.org. Join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.